Okay, so today we're going to see about Kirchhoff's law and analysis. The analysis consists of that one node analysis and mesh analysis. That node analysis and mesh analysis. That node is nothing but a Kirchhoff current law, and mesh is nothing but a Kirchhoff voltage law. That's all. Plus Ohm's law. Plus Ohm's law. You will going to add. So this is about that one. It is one of the major portion in the problem oriented topic. The problem is the whether it is possible to come on that one. So last class we were discuss about the what is the definition of the node and what is the definition of the mesh, and node is nothing but a Kirchhoff current law plus Ohm's law. Mesh analysis is nothing but a Kirchhoff voltage law plus Ohm's law. Okay, what is a supernode? Supernode is nothing but between the node. Okay, between the node here is there. So between the two node, voltage source is present means that is called a supernode. Okay, then what is a super mesh? Super mesh is nothing but a mesh means loop. Mesh means it is called as a loop. So I have in the circuit. Okay, in the circuit. Okay, two loop is there. Okay, so between the two loop, commonly okay intersecting point is a current source is present means that is called a super mesh. Then only you can call it as a super mesh. Otherwise, don't call it as a super mesh. Otherwise, it is called as a mesh only. Okay, fine. Okay, let's we go ahead on the Kirchhoff's law. Okay, Kirchhoff's law, it consists of the two is there. One is the Kirchhoff current law, second one is the Kirchhoff voltage law. There are two law. What is the Kirchhoff current law? It is saying, okay, very simple. Okay, sum of the current is equal to 0. Sum of the current. What is the sum of the current? Incoming current is a plus, outgoing current is a minus. Okay, incoming current is a plus and outgoing current is a minus. I hope it is already studied. You are easy to understand. Okay, for example, in the class, okay, a C class, okay, total strength is a 90. Total strength is a 90. How many boys? 50 is a boys. 50 is a boys is a plus. How many girls? Girls is a 40. So plus 50, okay, that is a denoted for the boys, and the minus 50 is a denoted for the girls. Okay, it is equal to 0. Why it is equal to 0? It is a sum of, okay, sum of the boys is a another one. Actually, it is not a correct way say. Okay, so okay, what I will going to say, 50 is a boys is staying inside the classroom. 40 is a girl student is moving outside the classroom. Okay, outside the classroom, they are moving outside the classroom. So inside the classroom, those who are staying coming to the inside the classroom, that is called plus 50. Those who are going outside the classroom, that is called minus 50. Minus 50. Okay, so those who are going outside the class, minus 40. Okay, minus 40. So very simple to say, it is a incoming current and plus outgoing current. Incoming current plus outgoing current. Incoming current denoted as plus, outgoing current denoted as a minus. Okay, in the network you will go to in the circuit you will go to see. So I1 is in the node. Okay, in the node point, I1 is the incoming current. So I1 is a plus, and further anything plus, I3 is a plus. Okay, that's all. Okay, I1 plus, I3 plus. Okay, and what about outgoing? Outgoing there are two. I2 is minus, I4 is minus. That's all. It is total, it is equal to 0. So incoming current plus outgoing current, it is equal to 0. So sum of the current, okay, see here the statement you can say algebraic sum of current in a node is equal to 0. Or another time what you can say, incoming current is it is equal to outgoing current. So plus current is one side, okay, that means boys is one side. Okay, otherwise those who are staying inside the boys is staying in 50 is inside, it is equal to those who are left the classroom, that is girl student, that is a 40 in the, it is equal to 40. 50 equal to 40 you can say. So sum of incoming current is equal to sum of outgoing current. So this is about the Kirchhoff current law. So you will going to write the statement, write the equation like that one only. Incoming current is denoted as a plus, outgoing current is denoted as a minus. That's all. Kirchhoff voltage law. Kirchhoff voltage law also algebraic sum of the voltage is equal to 0. Sum of all the voltage in a closed path is equal to 0. Okay, algebraic sum of the all the voltage. Okay, so in a closed path is equal to 0. So this is about the Kirchhoff voltage law, or it is you can say another simple term about voltage rise equal to voltage drop. See here is what is the voltage rise. So here is a 10 voltage. So 10 voltage it is a voltage rise. It is equal to what is the voltage drop? VR1 plus VR2. That is the voltage drop. Okay, see here, voltage rise is a plus Vs. Okay, drop is you have minus VR1 minus VR2. What is a V? V is a I into R. Ohm's law, I into R. Okay, so here you can say this is the equations. Okay, voltage rise is a plus Vs. Okay, they are suppliers and they are consumers. Consumer 1, consumer number 2. V1 plus V2. V1 means what is the IR1, IR2, and that further they are simplified. Vs equal to chi is common R1 plus R2, excuse me, R1 plus R2. So this is R equivalent. So R equivalent. Okay. This is about that one. Voltage division rule. What is the voltage division rule? I have written, see, VR1. So VR1 you want means I into R1 you can find out. I value if you know, directly use, otherwise use this direct formula. Supply voltage multiply R1 divided by R1 plus R2. So this is about the voltage division rule. Similarly, voltage division rule across the R2. So VR2 is equal to I into R2 or Vs into R2 divided by these two summations. Okay. One more example for that, Kirchhoff voltage law. So here is a supply voltage. Okay, see here, there are two voltage sources present. Then how to denote it for that one voltage? See here, it is moving. Okay, first one you will going to denote the voltage value. Even resistance, I will going to denote it for voltage. What is that one? V1, V2, V3, V4, V5, V5. There are totally 1, 2, 3, 4, 5 voltages there. Totally 5 voltage. Okay. My arrow mark is this is a loop. Okay. I will go to this is a closed loop. So I will going to draw about that my own assumption. I will going to draw the arrow mark. Okay. So my arrow mark is started here. Even it is called clockwise. Okay. So I am entering to which place? Am I entering to the plus place or minus place? If it is minus place means minus V1. If I am entering in the point, it's a again it is the minus place. So minus V4. Okay, that's all. So that is only important. I am entering to which place? First one, I am entering into the minus place. So I am entered. My arrow mark is start to enter. So enter into the minus place. Okay, so minus. So minus V1 plus V2. Okay, plus V3. I am entering again minus. So minus V4 plus V5. Then, so who are the minus? This one and this one. So V1 plus V4 and move on the opposite side. So minus term, that is move on the opposite side, plus terms. Plus term, remaining is the terms. So these two is a voltage rise. This two is a voltage drop. How do you say it is a voltage rise? Because these two is a supplier. These three is a consumer. So that's why here written voltage rise equal to voltage drop. Okay, so this is one of the very important and easiest problem. Just you will going to look it about that one. Okay, Kirchhoff's law based they will going to find. Okay, see at node point A. Okay, at node point A. Okay, where is the node point A? So this is a node point A. So what is the sources they are given? Current sources they are mentioned. This is called current source denotions. This is about the voltage source denotion. Arrow mark you can see current source. Okay, at node point A. Okay, in the node point A, you will going to find out what they are going to ask you. Okay, yeah. So in the node point A, what is the current? See here, current I is a what is a I is a flow here. I is a flow. In the after I is a flow, further it will going to divide it. What is the divided? Further it will going to divide it on the 2 point. What are the 2 point? One is a flow here. Okay, 5 amps plus I4. So 5 amps I4. What is that one? I is a 10 amps. So 10 amps equal to 5 amps plus I4. So from that one, can you find out the I4? Yes, easily you will going to find out. So 10 amps is there. This is a 5 amps is there. 5 amps move on the opposite side. Okay, 10 minus 5, it is equal to 5. That's all. So at node A, what is the amps? Similarly, at node B, what is amps? So at node B, what do you have? See that one. Okay, the arrow mark, everything is given. So incoming current, okay, outgoing current. So how many incoming current? Only one incoming current. What is the one incoming current? 5 amps. So 5 amps, it is equal to outgoing current 2 amps plus I3. at node B. So what is the current at node B? So 5 amps is incoming, outgoing is a 2 amps plus I3. Then you will go to find out the I3 value. Similarly, at node C, at a node C. So can you find out the current across? Can you find out the current at node C? Then node C, what is that one? Incoming current is I3 plus I4. It is equal to I5. See here. This is that one. Incoming current, what is that one? I3. Write it. I3. Okay. Plus incoming current I4. Okay. It is equal to I5. So already you found the I3 value and I4 value. Substitute 3 plus 5. 3 plus 5, 8. So that is I3. Sorry, what is that one? It is equal to I5. So that's all. 8 amps. So they will ask you find out the current of the at node A. Node A, what is the current? And node B, what is the current? And node C, what is the current? Very simplest problem. Then next one more problem. This is a voltage. Okay, voltage source is present. Okay, in the voltage source, okay, they are not giving for VR2. So VR1 is given and VR3 is given. So supply voltage V is equal to VR1, VR2 plus VR3. Okay. Supply voltage V is equal to VR1 plus VR2 plus VR3. See here, I will going to use on that one V is equal to, suppose I will going to move this V, this side means minus VA. Okay, this V I will going to move here means minus V. Okay, but I will going to keep here. Then what is my voltage? 10 voltage. Okay, then VR1, what is given or not? Yes, given. 4 is given. Then VR2 given? No, VR2 is not given. That is not known. Then VR3 is given? Yes, given. 2. Okay, so 2 plus 4 is equal to 6. Then we have to keep it here. Okay, 10 minus 6. 10 minus 6, answer is a 4. See, that's all. So this is about the Kirchhoffs law. So this is one of the simplest problem for find out the Kirchhoffs law. Okay. So you will going to use, see here what is there. Okay, the loop method. Okay, 1 2 3 loop is given and the voltage source here and the voltage source is here. Then you will going to assume your arrow mark I1, I2 loop, I3 loop. Then find out the I1 value, I2 value and I3 value. Okay, then you will going to form the equation only your work. Another one is if once you will going to form the equation, your calculator is there. Your calculator directly will going to substitute the delta value. Okay, and this value will going to directly possibilities there. If you are going to substitute, then you will going to directly get the what is I1 value, I2 value and I3 value. See, I will going to take the assumption of that one first loop, this is the arrow mark, and the second loop, this is the arrow mark, and the third loop, this is the arrow mark I will going to assume. Okay. So once assumed, I will going to start to write. So my arrow mark is entered into the minus or plus. So minus. So minus means, okay, I will going to keep it on this one on the left hand side. Okay, so 50 I will going to keep. Otherwise, if I will going to keep it means I already said, okay, minus 50. So minus 50 I will going to move only one direction. So I mean I will going to keep on that one another direction. So plus 50. So plus 50 it is equal to, so 15 I1 and this 1 ohm is common for these two. So 1 ohm is common for these two means you will going to look it here, enter this current, I1 is enter, I2 is a opposite. So my loop inside it is I will going to write, so I1 minus I2. Okay, then after that I will enter to the plus terms. So see here plus term, so plus 5. Then further you can simplify 15 I1, 1 I1. So 15 plus 1 is equal to 16 I1 minus I2. This plus 5 move opposite side, minus 45. So first equation is completed. Then similarly you can go ahead on the second equations. So second equations, see 5 I2 and 10. So 10 into my current, because my loop is the I2 loop. So my I2 loop, I3 is opposite. So I2 minus I3. Yes, I have written minus I3, and coming here I am entered into the minus 5 volt. So minus term. So minus 5 volt. Yes, plus 1 into I2 opposite. So I2 minus I1. That's all. This is the equation is formed. Then after that, this 10 you can move inside. This 1 is you can move inside, and further you can simplify. How many I2? 5, 10 and 1. So totally 16 I2. And how many I1? Minus 1 I1. How many I3? Minus 10 I3. That's all. Equation number 2 is a derived. Then similarly you can go ahead and the equation number 3. My current is entered to the plus term, so plus 10. 10. 10. I'm directly I have written. I will write. So 10. I will going to enter into the 10 plus 10. Plus next one, what is I have? So 10. Open the bracket. My I3. This is my third loop. So I3. This is a common for these two loop. So I2. So both also same direction or opposite direction. If it is the same direction means you will going to denote the plus term. It is opposite direction means minus I2. Then this it is equal to 0. Then plus 10, 10 is move opposite side. So minus 10. Then this side what is there? This 10 is you can move inside. Minus 10 I2 plus 10 I3. That's all. I have written. So what are they missing here? I1 is missing. So I1 is missing means what you can write? 0 I1. What is missing here? I3 is missing. So 0. Then use the calculator. Directly you will going to substitute and you will going to find out. Else you will going to do it by your own. If you want to find out I1 means what is the formula? I1 it is equal to delta 1 divided by delta. Delta 1 divided by delta matrix you should know. What is the delta? This is a delta. So you can write delta. So 16 minus 1 0 minus 1 16 minus 10 0 minus 10 plus 10. So this is a delta. This is a delta. Delta 1 means what? So this 45 5 10. This is a coming to the first column. So first column replace. So this place is a replace means that is called 45 you will go and write, and the 5 you will go and write, and the 10 you will go to minus 10 you will go and write. So you will going to get the delta 1. So delta 1 you will going to find out, and delta you will going to find out. Then I1 is over. Similarly I2 is over, I3 is over. One more problem we're going to see about the one more problem. Find the current, voltage and the power in 5 ohms. Where is the 5 ohm? So this 5 ohm they are asking the questions. Then so you will going to apply for that one law, Kirchhoffs law. Then it is a loop method we will going to form, and then KVL. First loop and that one, and the second loop we will going to do that once. So here I will going to enter into that one. So 20. So minus 20 instead of that one I will going to keep it on one side. So 20 it is equal to 10 into I1 enter to the plus terminal. So plus 10 into I1 into I1 opposite side. I2. So I1 minus I2. That's all. So first equation is ready. Similarly, I will go to the loop number 2. My loop number 2. I am entered to the plus 5. 5. So 5. And 5 I2. And 1 into I2. 1 into open the bracket I2. And this opposite side. So opposite means minus I2 minus I1. That's all. Simplify. You are going to get the equation number 2. So equation number 1 and equation number 2. Then you will going to get the I1 and I2. What is that one? I1 is equal to delta 1 divided by delta. So if you are yearly method, you are going to use the you are going to solve the delta 1 delta. but now you are engineering, you are going to use the calculator, you have the permission to use the calculator. Your calculator directly you will going to enter the first equation and the second equation, then you will going to find out the I1 and I2 fastly, else you will going to use the formula. So I1 is equal to delta 1 divided by delta, and I2 is equal to, what is the answer, delta 2 divided by delta, delta 2 divided by delta. Okay, then once you will going to find out the I1 value and I2 value. Okay, once you will going to find out. So what is that one I2 value? I2 value is equal to minus 9 by 13. So 9 by 13, that is called I2 current. So I2 flow of the current is this 5 ohm current. Flow of the current is, what is that one? Minus 9 by 13. That's all. So 9 by 13 you will going to flow of the current. Then what is the voltage across this point? What is the voltage across this point? You know Ohm's law. V is equal to I into R. I into R. So do you know I? Yes, I know. Minus 9 by 13. Yes, okay. R value do you know? Yes, 5 ohm. Then you will going to substitute and then you will going to find out the V value. So here Ohm's law I into R. Then answer is written. This is the voltage across. Voltage across is written. The next one, what is the power across the resistance? Power across the resistance. Power formula. Power formula, what is that one? General power formula V is equal to V into I. And what is the power across the resistance? Power across the resistance equal to last class we were seeing I squared R. I squared R. I squared R. So I value do you know? Yes, minus 9 by 13. Substitute the 9 by 13 whole square, multiply 5. 5, what is the 5? Resistance value. Yes, substitute. Then what is the answer? 2.396. That's all. So this is about the, so here is a arrow mark is denoted for current law, and then voltage rise equal to voltage drop is called a voltage law. That's all. So your problem is combined both Kirchhoff current law and voltage law. What is the current law? It's arrow mark. Arrow mark, incoming current, okay, is a plus symbol, outgoing current is a minus symbol. Okay, that is a Kirchhoff current law. Voltage law is, what is that one? Voltage rise equal to voltage drop. So this is about the Kirchhoff's law. One minute. Okay, followed by the Kirchhoff's law. It is followed by Kirchhoff's law only, node analysis and mesh analysis there. Okay, node analysis, mesh analysis, super node, super mesh. Okay, I will tell you introduction on today class, then followed by the next class. Particularly this node analysis, mesh analysis, so many methods used to solve the problem. That one I will tell you openly. So many methods used to solve the problem. Simple method you will going to use means I will going to give you in the topic simple method. Here where is a node? So this is a point is node and this is a point is node. So using node analysis, find VAB. So VAB. So they will going to ask you to find first what is the VA you can find out, what is the VB you can find out. So VA we will going to find out the VA equation and the VB equations. Then after find out the VA equation and the VB equations, and then VAB what is that one? VBA is equal to VA minus VB. Then you will going to find out the VBA. So VBA equations. Okay, so VBA equation you will going to find out on that like that once. Okay, and the next one VBA and the current through 30 ohm resistor. Where is the 30 ohm? So this is a 30 ohm across. Okay, what is the 30 ohm? I is equal to VA divided by 30. VA divided by 30. I is equal to V by R. V, what is that one? VA divided by 30. So you can VA, you know, substitute the VA divided by 30, then you will going to find out the answer. See, coming to that one, very simple. I will going to give the one outline. Okay, node. What are the nodes? They are given in the problem. There are two nodes. One is a VA node, then the VB node is given. Okay, this method VA can in the node. Okay, all the lines are outward directions. This is the one of the methods. Assume all current moves outward. Assume all current are move outward. That's all. You will going to start to write. So this is a method to you will going to solve the problem. So another method is there. I don't want to. One more method is there. They will going to assume some direction is there. Okay, from based on the source they will going to assume. Okay, this is a outward direction. This is a inward directions. Like they will going to give on that once. This is a one of the method. What is the method? What is the method of the one method means assume, this is a point note down, assume all the current move outward direction. That's all. So say see that one VA is a one node. All current is move outward or not? See, then you will going to proceed easily. This is one of the easiest method. Then similarly, VA is over, then VB. VB, all the current is move outward, then proceed. That's all. It's a very simple to one page, easily completed. Okay. Similarly, what is here? So this is a C. Is this normal node analysis or super node analysis? Okay, between two node, yes, between two node, voltage source is present. If voltage source is present, then only you can say about the super node. But here is current source is present, so it is not a super node. It is not a super node. Okay, then what to do? Assume current at node move outward. Just you will going to write and start to write about the VA and start to write about VB. Over. Solve, simplify, solve. Over. The next one is a mesh analysis. Mesh analysis is as similar to the Kirchhoffs law. So Kirchhoffs law, what you will going to do? That is same Kirchhoffs law you will going to use. So I1 you will going to assume, I2 you will going to assume, and I3 you will going to assume, and then you will going to find out I1, I2, and I3. That's all. Okay. So here is nothing. Okay, simple as your own style. You will going to arrow mark I1, I2, I3. You will going to note down. Okay. Then. So far we are what I covered you node analysis and mesh analysis. What is the super node? Super node means what? Super node is nothing but between the two node. See, what is the node? V1 is one node, V2 is no another node. Between two node, what is there? Voltage source is present. Voltage source is present. If voltage source is present between two node means you coming to know it is a super node. That's all. Then what to do? Then what to do means you will going to see here what is the voltage source is present. 12 volt is present. This 12 volt is present between which two nodes? Okay, between the V1 and V2. Then V1 and V2. So that one is a okay here. Okay, plus term. Where is a plus term? This is a plus term. V2 minus V1. V2 minus V1. It is equal to this answer 12. This is equation number 1. Okay, between two node. What are the two node? Plus term which side? V2 minus V1. It is equal to 12. Simple method. Okay. Then after that what you will do? Remove this one. What is that one? Remove means you will going to make the short circuited. Once it is short circuited means across what is that one? This is also short circuited. Short circuited means 0. This is 0. Short circuited. No use. No use. Remove. Okay, so short circuited. Then as usual, node 1, node 2. Okay, assume the current move outward direction. Then you will going to find out the equation number 2. Then simplify. So this is called a super node. Okay, super mesh. What is a super mesh? Super mesh is nothing but between the two loop current source is present means that is called a super mesh. Between the two loop is current source is present? Yes, it is a current source is present. Between the two loop current source is present. Okay, how the current source is present? Just you can look it. Current source is present in downward direction. So downward direction it is a present. Yes. How I1 is coming? I1 is coming on the same downward direction. So I1 same downward direction. So I1 minus I3 it is equal to 10. That is very important to write. I1 minus I3 it is equal to 10. That's all. Once equation number 1 is a frame, remove the current source. Previously open circuit. So previously voltage source is removed to short circuited. So now you will go to open circuit. So previously super node what you did? So voltage source is removed and close is short circuited. So short circuited means here open circuit. So open it. Then once it is open, then you will going to proceed as per that one. I1 you can keep it here and I3 is here. These two is I3. Then as usual loop. How many loop? One loop and another loop. Only two loop. So two loop you will going to write. Okay, and the only one equations. What is that one? Yes, minus 6 and 2 into I1. Yes, this is the equation number 1 and this is the equation number Yes, here, yes. So this is a one loop, and this is another loop. That's all. So this is about the introduction about the mesh, super mesh methods. So next class we will going to detailedly we will going to see this problem. Okay.